Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on analytical dynamics or classical mechanics, chapter variational principle, lecture number 5, in which I will derive Lagrange's equation of motion from Hamilton's principle. Now we solve the question. Derive Lagrange's equation of motion from Hamilton's principle. Answer is, according to Hamilton's variational principle, motion of a conservative system from time t1 to time t2 is such that the variation of the line integral I equal to integration limit t1 to t2 Lagrangian function L, which is function of qi dot and t. Qi is the function of t and qi dot is also function of t. Here dt. According to variational principle, the variation of this line integral is 0. That is delta I equal to 0. If we account for all possible paths of motion of the system in the configuration space and label each with a value of parameter alpha, then paths may be represented by set of all qi be the function of t and alpha, and corresponding I integral will be a function of corresponding alpha. Now we write the corresponding integral for corresponding alpha, I alpha equal to integration limit t1 to t2 Lagrangian function is the function of qi dot and t. Here qi be the function of t and parameter alpha. Qi dot is a function of time t and parameter alpha. Now taking partial derivative of I alpha with respect to alpha equal to integration limit t1 to t2 partial derivative of L with respect to qi partial derivative of qi with respect to alpha sigma I plus sigma I partial derivative of L with respect to qi dot partial derivative of qi dot with respect to alpha plus partial derivative of L with respect to t partial derivative of t with respect to alpha bracket close and here dt. This is number 2. Since in delta variation there is no time variation along any path and also at the end points, and hence partial derivative of t with respect to alpha equal to 0 along all paths. Therefore from 2 we get partial derivative of I alpha with respect to alpha delta alpha equal to, we take sigma outside I integration t1 to t2 limit partial derivative of L with respect to qi, partial derivative of qi with respect to alpha delta alpha plus sigma I integration limit t1 to t2 partial derivative of L with respect to qi dot partial derivative of qi dot with respect to alpha delta alpha. Here dt, here also dt. Since partial derivative of t with respect to alpha is 0, so we do not write this term. Let this is number 3. The second term of right hand side equal to sigma I integration limit t1 to t2 partial derivative of L with respect to qi dot partial derivative of qi dot with respect to alpha delta alpha dt, and this will be equal to sigma I integration limit t1 to t2 partial derivative of L with respect to qi dot. We may write this partial derivative with respect to alpha qi dot is dqi by dt delta alpha dt bracket closed. This equal to sigma I integration limit t1 to t2 partial derivative of L with respect to qi dot. We use the commutative law. Firstly we write d by dt and inside partial derivative of qi with respect to alpha delta alpha dt. Now we integrate this by parts. Sigma I first function partial derivative of L with respect to qi dot integration of second, integration of this is partial derivative of qi with respect to alpha integration with respect to time t, here delta alpha minus integration of this is t1 to t2 limit differentiation of first d by dt partial derivative of L with respect to qi dot integration of second, this is partial derivative of qi with respect to alpha and delta alpha, and here integration, that means dt. Here limit t1 to t2, here bracket closed, equal to sigma I bracket partial derivative of L with respect to Qi dot, and this is delta Qi T1 to T2 limit minus integration limit T1 to T2 d by dt partial derivative of L with respect to Qi dot partial derivative of Qi with respect to alpha delta alpha dt. Let this is number 4. Since Qi's are fixed at endpoints, means coordinates at the endpoints be fixed. Therefore, delta Qi equal to 0, means variation of the coordinates at endpoints is 0. Hence, the first term of right hand side of 4, this is the first term. Here, when time equal to T2, delta Qi equal to 0. When time equal to T1, delta Qi equal to 0. Therefore, the first term will be equal to 0. This term will be 0. Hence, 4 may be written as, this is the left side, we write the left side, and right side will be the second term of 4, right hand side of 4. This is, and this is number 5. Using 5 in theory, we get left side is delta I alpha and right side is sigma I integration limit T1 to T2 partial derivative of L with respect to Qi partial derivative of Qi with respect to alpha delta alpha delta t minus sigma I integration limit T1 to T2 d by dt partial derivative of L with respect to Qi dot partial derivative of Qi with respect to alpha. So here will be del alpha dt implies that delta I alpha equal to sigma I integration limit T1 to T2 partial derivative of L with respect to Qi minus d by dt partial derivative of L with respect to Qi dot partial derivative of Qi with respect to alpha delta alpha dt. This is dt. This is number 6. From 6 we get here partial derivative of Qi with respect to alpha delta alpha equal to delta Qi. Since all Qi be the generalized coordinate, means all generalized coordinates are independent with each other. Therefore, the variation delta Qi will be independent. Hence, delta I alpha will be equal to 0 if and only if coefficients of delta Qi separately vanish. Therefore, from 7 we get 0 equal to separately vanish, means for each alpha we get this 0, and also we get here partial derivative of L with respect to Qi minus d by dt, partial derivative of L with respect to Qi dot, this is Qi dot, implies that d by dt partial derivative of L with respect to Qi dot minus partial derivative of L with respect to Qi equal to 0. Here I equal to 1, 2, dot n. This is the Lagrange's equation of motion. So we have derived the Lagrange's equation of motion with the help of Hamilton's principle. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.